In this video, we're going to be talking about trig functions at any angle. So I'd like to start off first with these two pictures that I have on the board. So if we look at the left, this is just the output of a calculator. And notice that we have four different angles all evaluated using the same trig function sine. But the thing to remember here is this. Notice when the sine of 20, or when we evaluate the sine of 20, we get 0.342. The sine of 160 also is at 0.342. Sine of 200, negative 0.342. And finally, the sine of 340 is negative 0.342. So if you look at these four results, they're all the same except for the sine. And the reason for that lies right here. So I'm highlighting 20 degrees. And that's because we consider that to be what we call a reference angle. So the definition of the reference angle is below. The reference angle, theta ref, of a given angle is the positive acute angle formed between the terminal side of theta and the x-axis. So your book actually has a really nice example. It's the very first example, so I'm just going to copy and paste it into our notes. And it demonstrates how we get the reference angles. So anything in quadrant 1 will have its own little reference angle, which is basically the angle itself. All right. Now, in quadrant 2, the reference angle will always be 180 minus theta, whatever that angle happens to be. So, for example, if the angle is 150, the reference angle would be 180 minus 150, which is 30. Now, in quadrant 3, the reference angle is going to be the angle minus 180. So in this example, if the main angle is 230, then its reference angle would be 50 degrees. Then, in quadrant 4, the reference angle is going to be 360 minus theta, which is whatever the measure of the angle is. And then the last picture shows basically the reference angle of 60, which is the reference angle for 420. Now, what this here is saying here is this, is if you have a 60-degree angle, that is the same exact thing as a 420-degree angle, because if you just rotated that angle again 360 degrees, you would get back to 60 degrees. Then you can keep rotating it over and over again. All right? The one thing you always remember is what quadrant are you in? Remember, all students take calculus, meaning all the trig functions are positive here, sine and cosecant here, tangent and cotangent here, and cosine and secant here. Because the thing to remember is, let's say you have an angle that looks something like this. All right. And theta equals, let's say, I want to pick a good number here to kind of like prove a point. All right. How about this? How about sine theta equals 0.348. Okay? Well, if you wanted to figure out what theta is here, remember, we would take the inverse sine of 0.348, all right, and that's going to equal, let me get out my calculator real quick. All right, so inverse sine of 0.348 equals 0.355. Oh, wait. Hold on, I think I'm in the wrong mode. Yep. I need to be in degree mode. Sorry about that, everyone. We're going to fix this real quick. Let's do this again. And this would be approximately, so theta would be about, we'll say 20 degrees. All right? Well, the thing here to remember is that's just one answer. Because the other answer could be 180 minus 20, or could be over here at 160 degrees, which our reference angle would still be 20 degrees. All right, so sine has two answers. All right, you got to tell us which one you're dealing with. Or I think where it really like kind of comes all together is when you're doing like an application type problem, where let's say you could be standing at the origin and you are kicking, maybe you're kicking a football or something like that. All right, and the trajectory is going out that way to the right. Well, here it's clearly obvious then that we want the angle 20 degrees because you're kicking it from standing at the origin to the right. But if you were kicking it standing at the origin to the left, then the angle would be 160, or the reference angle would be 20 degrees. So you want to make sure that when you're talking about angles and reference angles, that you're using the reference angle to help you calculate your values. Now, as I said earlier, all right, a good, useful way to do this is right here. This will give you all your reference angles. And you just got to pay attention to what the information is given. That's all. So the last thing in 8.2 that we're going to talk about, or what is this? Yeah, chapter 8, section 2. It's just going to be negative angles. Okay? So your book, once again, I'm going to just screenshot the book real fast because it gives an excellent description. Is right here. So whenever we're talking about negative angles, remember, going up this way, positive, down this way is negative. So at the top of the screen right here are all the relationships. So like, for example, the sine of a negative angle is equivalent to negative sine theta. All right. The cosine of a negative angle is equal to cosine theta. Tangent of a negative angle equals negative tangent theta, and so forth. So depending upon if you are above the horizon, so this would be above horizon, or below the horizon, you would go ahead and just use this chart above just to algebraically fix your problem so that it meets the needs that you have. And that's going to be it for this video. See you in the next one.